Hello everyone, my name is Keith Brown with Envera Systems, and in this presentation I'm going to describe our real-world usage of Shlaer-Mellor modeling with BridgePoint xtUML. At Envera Systems, we provide access control to gated communities. Our operations encompass hundreds of gates that run around the clock every day of the year. When visitors arrive at one of our gates, they are stopped by a barrier arm and they use a kiosk like the one you see here. The kiosk includes scanners, audio-visual devices, and a display that plays videos that guide the visitor through the entrance validation process. This process starts with our system attempting to automatically validate the visitor with a license plate, a driver's license, or a QR code lookup. If validation fails, the visitor is connected to a remotely located human agent for manual validation. Once the visitor is verified, the barrier arm opens and a video plays that instructs them to proceed through the gate. As you can see, our solution relies on a mixture of interconnected hardware and software. Each site has several signal wires that provide input to the software via a USB I/O device. These include sensors for both a ground loop and a push button that notify us when a visitor is present at the kiosk. There's a signal wire that also allows us to see when an agent is using the speaker and microphone inside the kiosk to communicate with the visitor. There's also a signal wire that we monitor to know when the gate has been instructed to open. The original procedural code that monitored the USB I/O device to drive the video playback suffered from various bugs and crashes. While the problems were not fatal to our ability to serve visitors at the gate, the problems did lead to a poor customer experience that certainly made our system look bad. Obviously, this is not what we want. As our team discussed potential fixes, we recognized the event-driven, stateful behavior of the activity at the gate. It made perfect sense for us to model an xtUML state machine to capture what is happening and to make the system work as intended. The state machine includes thoughtful use of watchdog timers and a fully defined state event matrix for proper specification of ignorable and error case transitions. We were pleased to be able to reason through proper functionality with cross-functional teams using the graphical state machine diagram. We then used the MC3020 code generator to translate the model into C that was compiled into an application for the Windows platform that runs inside the kiosk. The generated application underwent numerous test cycles, where we fed simulated input signals into the application over a network interface. Each test included predefined expected results that were programmatically compared against the actual results of the runtime behavior. After years of runtime, we were convinced that the model application provides a vastly improved visitor experience and provides the stability we need in our always-on environment. We are so pleased with what we've been able to achieve that our next phase will give the model even more responsibility and intelligence. The existing model takes input over a simple socket interface. For our next version of the model, we have integrated with the networking library libcurl. This gives us the ability to make outbound network calls to other parts of the system to drive functionality when state changes occur. The inbound network interface has also been extended to talk to the PLC. This gives the model access to many more I/O signals that are used for additional processing and decision-making inside the modeled application. It also eliminates the USB I/O device, which saves cost and removes a potential point of failure. I mentioned previously that the model exists inside a larger system. In this diagram, the application model, which is the little yellow box, is just one piece in a whole ecosystem of .NET microservices that run at the site. So we're now well beyond simply making sure the video display is correct. The kiosk state machine model is now a core piece of the visitor processing as well as the visitor experience. We are already envisioning new ways to grow the application model to make our visitor processing more intelligent and efficient. I hope you have enjoyed this quick look into Envera's real-world use of Shlaer-Mellor modeling with BridgePoint xtUML. Thank you for being a part of this community, and I look forward to hearing about your experiences applying executable and translatable modeling to your own applications.